In this video, we're going to focus on the negative exponent rule with the properties of exponents. Now remember, if a negative exponent is on top of the fraction, that means we move it to the bottom of the fraction and make the exponent positive. If it's on the bottom of the fraction, we move it to the top and make the exponent positive. So if we look at the first example, we have a cubed times b to the negative second. So our a cubed is fine. It's perfect as is. What I'm going to do is I'm going to create it, since we saw in both of these descriptions that if you have a negative exponent, it needs to go on the other side of the fraction. Let's just create this as a fraction, write it as a fraction. So the a cubed is going to stay where it's at. My b to the negative second, the negative has nothing to do with the power. It has to do with the position. And so since I have a b to the negative second in the top of the fraction, that means I have to move it to the other side, the bottom, and I make the exponent positive. So the final answer I see is a cubed over b squared. And I could try it in this example, 2a squared over b to the negative third. So I mean, the 2a squared is perfect as is. I mean, there are no other like bases with the a, and there's no coefficient to simplify with the 2. But I see my b to the negative third. And so since I have a negative, that means my position for this term is wrong. It needs to be on the other side of the fraction. And so I'm going to move it to the top and make it positive. And so that is the basic understanding of the negative exponent rule. The negative exponent has nothing to do with the sign, either positive or negative of the value. It has to deal with the position of the value. Now, I like to think of a shortcut when dealing with the negative exponent rule to kind of make it easier and quicker and less work to show. And what the shortcut is you need to think about the fraction bar, like the equal sign for exponents. And what I mean is, when you solve an equation, if you want to move a term from one side of the equal sign to the other, you're going to perform the opposite operation. So if I want to move the 5 to move to the other side, I'm going to subtract 5. And you need to think about the fraction bar as the equal sign for exponents. If you want to move, a base in the exponent to the other side, you have to perform the opposite operation. And so with negative exponents, it becomes pretty easy, where I have an x to the negative fourth. So to move it to the other side, I'm going to perform the opposite operation, which means I'm going to add. And so this x to the negative fourth, I'm adding to the bottom, so it's going to be a positive 4. This y to the negative third, to cross over the fraction bar and move it to the top, I have to add, which makes it a positive 3. That z just stays where it's at because there's no other base to compare it to. And so 3y cubed x to the fourth z. And let's try it over here. There's no other coefficient. So I'm going to put my long fraction bar. I'm going to leave the negative 2 alone. My x squared, there's no other x in the bottom, so my x squared is going to stay alone. My y to the negative fifth. So again, I see a negative 5. So to bring this to the other side, I'm going to have to do the opposite operation of the exponent, which means it's going to add, so a positive 5. My z to the negative 6. To move this to the other side, I'm going to have to do the opposite operation for this. And so I see it's a negative 6, so I'm going to add, make it a positive 6. We see this a squared, there's nothing to compare it with. So again, your variables go in alphabetical order. So my a squared is going to go over here. B to the negative fourth. I'm going to have to move it to the other side because I see a negative exponent. So I'm going to have to add it. So it becomes a b to the positive fourth on the other side. And like I said, your variables need to be in alphabetical order. So I need to rewrite this so that b to the fourth comes before the x squared. And the bottom is in alphabetical order. So I'm just going to repeat it. And so my final answer is negative 2b to the fourth x squared over a squared y to the fifth z to the sixth. So that's the negative exponent rule. It has nothing to do with the sign of the expression. It has to do with the position of the expression. If you see a negative, it means you have to move it to the other side and make it positive from there.